Hello and welcome back, everyone. My name is Heriberto Eri Ramirez, and today's presentation is going to be on metadata for successful AI generation, specifically art creation. So, sounds like a little handful, but let's go ahead and jump in as we will be discussing the importance of metadata in the creation of art using artificial intelligence platforms and how this information can be utilized effectively. Artificial intelligence has seen rapid growth in recent years, revolutionizing various fields, including the world of art. AI-generated art is becoming increasingly popular as algorithms and machine learning techniques are now capable of creating visually appealing and thought-provoking pieces. But to achieve this success, AI relies heavily on metadata. Metadata, which can be defined as data about data, plays a crucial role in AI-generated art. It provides essential information about the elements and characteristics of a piece of art that allows AI systems to learn and generate new, unique creations. In the context of AI-generated art, metadata includes details about style, content, color texture, image resolution, and format. In this presentation, we will explore how metadata can be effectively utilized in various AI platforms for art creation and examine specific examples of AI-generated art. By the end of this presentation, you will have a better understanding of the importance of metadata in AI-generated art and how it can be used to create stunning original pieces. Now, let's take a look at some popular AI platforms for art. These platforms leverage artificial intelligence and machine learning algorithms to create visually captivating and unique pieces of art. First, we have DeepArt, a platform that uses a technique called neural style transfer to combine the style of one image with the content of another. By feeding the AI system metadata about the style and content, DeepArt can generate a new image that marries the two elements in a visually coherent manner. Next, and I do get excited about this next one because it is my personal favorite. Next, we have DALL-E, developed by OpenAI. DALL-E is an AI model that can generate unique images from textual descriptions. It can create a wide range of images by interpreting the metadata provided in the form of text, allowing for an impressive degree of creativity and flexibility given the user's ability to manage the text. Lastly, ArtBreeder is a platform that allows users to blend and create new images by leveraging a technique called Generative Adversarial Networks, also GANs. Users can provide metadata about the desired feature, and ArtBreeder will generate a new image based on the input. This platform is particularly popular for creating concept art and character designs. However, for AI-generated art to be successful, it is crucial to have access to high-quality and diverse datasets. These datasets provide the foundation for AI algorithms to learn and understand the nuances of various art styles and elements. One such dataset is ImageNet, a large-scale dataset containing millions of images that have been manually annotated with metadata, including information about objects, scenes, and actions. ImageNet has been instrumental in advancing AI research and has contributed to the development of various art generation platforms. Another dataset is the COCO dataset, short for Common Objects in Context. COCO is primarily focused on object detection, segmentation, and captioning. The dataset contains images with annotated metadata, which helps AI models learn and understand object recognition and contextual relationships within a scene. Finally, we have the Doodle dataset, which consists of simple drawings or sketches made by users. These datasets provide a unique perspective on artistic expression and can help AI models learn to generate art that resembles human-made doodles or sketches. In summary, the quality and quantity of data plays a significant role in AI-generated art. By providing rich metadata and diverse examples, AI models can learn and generate more creative and visually appealing art. Data labeling and annotation are essential processes in preparing datasets for AI-generated art. They involve assigning specific metadata to each piece of art in the dataset which helps the AI model learn and recognize different artistic elements and characteristics. Some common metadata used for data labeling in art include style, subject, and composition. Style refers to the artistic movement or technique that the artwork belongs to, such as Impressionism, Cubism, or Abstract Expressionism. Providing this metadata allows AI models to identify and replicate the styles in their generated art. The subject metadata refers to the main focus or theme of the artwork, such as landscapes, portraits, or still lifes. By annotating images with information about their subject, AI models can learn to generate art that aligns with specific themes or subject matters. Composition metadata relates to the arrangement of elements in the artwork, such as the use of perspective, balance, and visual hierarchy. This metadata enables AI models to create art with visually pleasing and coherent compositions. Through proper data labeling and annotation, AI models can better understand the intricacies of various art styles, subjects, and compositions, ultimately leading to more successful AI-generated art. So let's talk about feature extraction. Feature extraction is the process of identifying and selecting the most relevant and informative characteristics from a data set, which are then used by AI models to learn and make predictions or generate new content. In the context of AI-generated art, feature extraction involves identifying the key visual elements and patterns in an artwork. Metadata plays a significant role in feature extraction for art, as it provides AI models with the necessary context and information about the artwork's characteristics. By understanding the metadata associated with each piece of art, AI models can effectively extract relevant features and learn the relationship between them. For example, if an AI model is trained on a data set of paintings and metadata about style, it can learn to extract features that are characteristic of specific styles, such as brushstroke patterns in Impressionist paintings, or the use of geometric shapes in Cubist art. This knowledge allows the AI model to generate new pieces of art to exhibit similar features and adhere to that specific style. In conclusion, metadata is crucial in the feature extraction process for AI-generated art. It provides AI models with the necessary context to identify and learn relevant visual elements, which ultimately results in more compelling and accurate art generation. However, as we dive deeper into the role of metadata in AI-generated art, let's examine style and content metadata in more detail. Artistic style metadata provides information about the specific art movement or technique that an artwork belongs to. Examples of styles include Impressionism, Surrealism, or pop art. By using metadata to describe and categorize the style of a piece of art, AI models can better understand the visual language and elements associated with that particular style, such as color schema, brush strokes, and subject matter. Then there's also content metadata. Content metadata, on the other hand, refers to the specific elements present in the artwork, such as objects, scenes, and emotions. This type of metadata helps AI models identify and recognize the visual elements and themes within a piece of art, allowing them to generate new artworks that incorporate similar content. For example, content metadata might describe a painting as featuring a mountain landscape, or maybe a sunset, or sunrise. In terms, you could also put something such as a sunset or a sunrise, and also an emotion, right? A sense of tranquility. By understanding these descriptive elements, AI models can create new artworks that capture similar scenes or evoke similar emotions, ultimately leading to a more engaging and cohesive AI-generated piece of art. Another essential aspect of metadata in AI-generated art involves color and texture. Color metadata refers to the color palette or range of colors used in a specific piece of art. This information can be crucial for AI models, as it helps them understand and replicate the color schemas that are characteristic of specific art styles or artists. For example, AI models can use color metadata to generate artwork with vibrant hues of Fauvism or the more subdued tones found in Baroque paintings. Texture metadata, on the other hand, is related to the surface quality or appearance of an artwork. This can include information about brush stroke patterns, such as thick, visible brush strokes of an impressionist painting or the smooth, blended strokes of a classical portrait. Texture metadata can also describe other patterns and surface features present in an artwork, such as the intricate patterns in a piece of Islamic geometric art. By incorporating color and texture metadata into their training processes, AI models can better understand the visual characteristics of different art styles and create new artworks that exhibit similar color palettes and surface qualities. This results in AI-generated art that is more visually cohesive and engaging, and as it can accurately reflect the desired style and content of a particular era, it will create art that is within the imagination of a creator in correlation or juxtaposition to that specific era and type of painting. Now, let's discuss the importance of image resolution and format metadata in AI-generated art. Image resolution metadata refers to the level of detail in an image, typically measured by dots per inch, DPI, or pixels per inch, PPI. High-resolution images contain more detail and are better suited for AI models to learn and generate art. Providing AI models with metadata about image resolution allows them to understand and create art at the appropriate level of detail. So what this does is it ensures that the generated images are visually appealing and suitable for various applications, such as printing versus digital display. Image format metadata refers to the specific file type of an image, such as JPEG, PNG, or SVG. Different image formats have varying levels of compression, color depth, and support for transparency. AI models can use format metadata to understand and generate image in the appropriate format, ensuring compatibility with different devices and platforms. For example, an AI-generated artwork intended for display on a website might be best suited for the PNG format, which supports lossless compression and transparency. On the other hand, though, a generated artwork for printing might require a high-resolution TIFF or TIFF file, which retains maximum image quality. An essential part of creating AI-generated art is training and fine-tuning the AI models. This process involves feeding the AI model a data set containing a wide variety of art samples along with the associated metadata. The AI models then learns to recognize and understand the relationship between different artistic elements based on the provided metadata. During the training process, the AI model is exposed to numerous examples of art, learning to recognize and replicate different styles, subjects, and compositions. This process is iterative, with the model continuously refining its understanding of artistic elements and adjusting its internal parameters to improve its performance. Fine-tuning is the process of adjusting the AI model's parameters to optimize its performance for a specific task or application. In the context of AI-generated art, fine-tuning might involve providing the AI model with additional metadata about the desired style, subject, or composition to generate artwork tailored to a specific theme or user preference. Metadata plays a crucial role in both the training and fine-tuning processes, as it provides the AI models with the necessary context and information to understand and generate art effectively. By incorporating diverse and detailed metadata into the AI model's training, we can create more accurate, engaging, and visually appealing AI-generated art. Which then leads us to our next topic. Measuring the success of AI-generated art can be somewhat subjective, as art is often evaluated based on an individual's preference and interpretations. However, there are certain evaluation metrics that can be used to assess the performance and quality of AI-generated art in a more objective manner. Style transfer accuracy is a metric used to evaluate how well an AI model has captured and replicated the style of a given artwork. This metric can be influenced by metadata related to artistic style, brush strokes, color palette, and texture. By comparing the generated artwork to the original style reference, we can assess the model's ability to transfer style effectively. There's also content preservation. Content preservation is another important metric. especially when generating art based on existing image or textual descriptions. This metric evaluates how well an AI model has maintained the original content of the source image or accurately represented the described content. Content preservation can be measured using metadata related to subject, objects, and scenes present in the original artwork. By utilizing metadata to evaluate these metrics, we can gain insights into the performance of AI-generated art platforms and refine the algorithms and models to create even more impressive and accurate art. As AI-generated art becomes more prevalent, the importance of personalization and catering to an individual user preference cannot be overstated. Personalization allows AI art platforms to generate artwork that resonates with users on a more personal level, enhancing the overall experience. Metadata plays a crucial role in personalizing AI-generated art by capturing and incorporating user preference into the art creation process. This can involve collecting metadata on users' favorite style, because this is actually a very important part. So in the art creation process for an individual, this can involve collecting metadata on users, meaning your favorite artists, styles, subjects, color palettes, or even specific themes and emotions they want to explore. By incorporating this user-specific metadata into AI models' training and fine-tuning processes, the platform can generate art that is tailored to individual preferences and interests. This not only increases user satisfaction and engagement, but also encourages users to explore and appreciate a wider range of artistic styles and expressions. In conclusion, metadata can significantly enhance the personalization capabilities of AI-generated art platforms, enabling them to create more engaging and meaningful art experiences for users. However, as we explore the potential of AI-generated art, it's essential to address the ethical considerations and copyright issues that may arise. AI-generated art can raise questions about ownership, originality, and the appropriate use of existing artwork and training data sets. Metadata plays a crucial role in addressing these concerns by providing information about the attribution and copyright. This can include metadata about the original artist, the date of creation, and the specific license associated with the artwork. By incorporating the metadata into AI-generated art platforms, we can ensure that proper credit is given to the original artist and that their work is used and shared accordingly to the established copyright guidelines. For example, AI models can be trained to recognize and generate art that falls under a Creative Commons license, which allows for more flexible use and sharing of artwork while still respecting the original artist's rights. By addressing ethical considerations and copyright throughout the use of metadata, we can create AI-generated art platforms that respect and honor the work of artists while enabling the exploration of new creative possibilities. As we look toward the future of AI-generated art, there are numerous potential applications and opportunities for artists, consumers, and researchers alike. AI-generated art platforms can be used for creating unique and personalized art pieces, developing new styles and techniques, or even assisting in art restoration and conservation efforts. Metadata will continue to play a vital role in advancing AI-generated art as it provides the necessary context and information for AI models to learn and create. By incorporating diverse and detailed metadata into AI model training, we can expect improvements in the quality, accuracy, and creativity of the art they generate. Additionally, the ongoing development and refinement of AI algorithms will enable AI-generated art platforms to better understand and replicate more complex and nuanced artistic elements, further pushing the boundaries of what is possible with AI-generated art. In conclusion, the future of AI-generated art is bright and full of potential. By harnessing the power of metadata and advancing AI algorithms, we can continue to explore new creative horizons and redefine the way we experience and create art. With all of that said, thank you for joining me today, and I hope you have enjoyed this presentation on metadata for successful AI-generated art creation. Thank you.